In this test, we're going to be taking a look at soil aggregates through what is called a wet slake test. Now, soil aggregates are the accumulation of soil organic matter that is produced by microbes, such as fungal hyphae, which produce a glycoprotein called glomulin. And the scientific names are not nearly as important as the fact that this is a cement or a glue-like material that helps to stick and clump together soil particles and also resist erosion from water. Now, in order to conduct this test, we just need a shovel and some bags to conduct our sampling out in the field, and then we'll take those samples back home in order to do the test in there. Now, the circumstances of your soil are important for this. You can't do this if the soil is saturated or in standing water. It won't work. However, unlike some of the other soil tests that we do, you can collect dry soil samples. It doesn't have to be totally moist, although that can help when you're digging, if you've got compacted soil, to get down into the lower layers, at least 20 or 30 centimeters down, where we're going to be getting our soil samples from. Now, it's always important before taking samples from the field to mark the geolocation either on a physical map or in a digital tool like Google Maps to make sure that you know where the sample comes from, and that your sample bags correspond with those locations. Now, this is one soil test in which the percentage of clay or sand is not going to make a huge difference in your results. Clay particles will break down in water, and of course sand will very rarely stay together under any circumstances. So the aggregates are really what are keeping it together regardless of the base minerals, and that's one of the things that's really useful in that the values of this are not going to be much different based on the minerals that you have in your soil. Now, you only need simple equipment to take your soil samples out in the field, a spade or a shovel to get down at least 20 or 30 centimeters into the soil to get various depths for your reference in your soil sample, and of course some plastic or Ziploc bags and a marker that you can label and write on them to keep them organized. In order to take your sample, make a hole in the soil. Look to collect pieces of soil from various depths. Be sure to label the samples that you're taking. Now, in this case, I know my soil is extremely sandy. I'm not going to bother to dig much deeper because I know I'm just going to get sand with very little aggregate potential. So I'm trying to get pieces that might give me some insight into the aggregate that I actually have in the more living strata of the soil that I'm testing. So here's a second spot that I'm going to try, hopefully for a little bit of contrast from the sandy soil back there. I'm going to get some of the organic matter off the front. I have a feeling that this is going to have better aggregate and texture. So I've already got my sample bag here for the berry patch. I'm already seeing a lot better texture and aggregate in this sample. So I have high hopes that even though this is still fairly sandy and silty, that this will give a better reading of aggregate in our tests. Remember to try and grab samples from various depths. So that's from deeper, and this is near the surface. That's all you need. All right, so here back at the house, I've got 2 plates that I've labeled that correspond with the different soil samples that I've got, because the first thing that we're going to do is select some small little clumps of soil between 1 and 3 millimeters in size and dry them out completely. This could take up to 1 to 3 days in most cases. Now I'm going to put these in a place out of the way to let them dry. So this is 3 days later, and I made extra sure that these samples are completely dry. Now we're ready to start our test. All you need is some sort of transparent container like this glass jar and a sieve or a colander. Now, something with large holes like for straining pasta, for example, won't work very well. This little tea strainer with very, very thin mesh is going to work a lot better. And what we're going to do is make sure that these little clumps of soil are no larger than 3 millimeters. 3 millimeters is very, very small. As you can see, most of these here are too large. I believe this one is just about right. Obviously, you have to be careful with it so it doesn't disintegrate. That's right about 3 millimeters. That's as large as I want it. So these other smaller ones here are about the right size. These ones I can cut down smaller so that they're appropriate for this test. And then I'm going to very carefully place these inside of this strainer and completely submerge it in water, and then set the timer for 5 minutes. All right, ready for the second test. I've got the small samples in here, ready to go into the water, which I've also changed with clean water, even though there wasn't any debris in it from the last test. Here my soil samples were floating at the beginning, so I just tapped on them lightly so they would sink to the bottom. So I was surprised to see from my test that the sandy low organic matter triangle plot really didn't fare much worse in the trial than the higher organic matter berry patch. And I know it has more organic matter because I put compost in it. But really neither of them muddied up or discolored the water at all, and the little clumps of soil that I used in the test didn't fall apart really in any noticeable way. Now that might not be the case for you. You might see them fall apart completely, you might see them discolor or muddy up the water, but even that is useful as a benchmark that you can then track any changes or improvements over time. And to make that easier to organize, for you to input the data, you can always use the farm health report card to do that. And hopefully you'll start to see changes that reinforce some positive actions or management that you'll be trying in your experiments in the future.